Okay, so we have finally reached the end. All I'm going to do right now is review with you a few brief notes from section 6.5 and 6.6, and then we're going to be reviewing and finishing up this chapter. So, in section 6.5 and 6.6, we learned that there were three different types of solutions. The first option is that there could be one solution to a system of equations. When there's one solution and you're looking at a graph of a system of equations, you are going to see two lines that intersect somewhere on the graph. When you see that there's one solution, you must give the solution in your answer. Now, if you're solving a problem and you are going to get one solution, then after solving, you're going to get something like x equals 3. Note here that not all the variables have canceled. And again, if you get x equals 3, then you must find y. And you have to then go back and tell me the answer at the end. Now, if there is no solution, then when you're looking at a graph, you're going to see two lines that never intersect. Because if the lines never intersect, then there would be no solution. If you're solving an equation, then when you get to the end, you're going to get something that is not true. And you will notice that all the variables have canceled each other out. Lastly, we could have a problem with infinitely many solutions. If you're looking at a graph that has infinitely many solutions, it's going to look like there's just one line on the graph because the two lines are actually directly on top of each other. And if you're solving an equation that has infinitely many solutions, you're going to get a final answer that is always true. You'll also note that all of the variables will have canceled. The second part of this is learning how to graph and also write the problems out for a system of inequalities. For this first graph, what I would do is I would start at the -1, I would go down 2 over 1 or up 2 left 1. And I'm going to use a solid line here since there is an equal to symbol. And I'm going to shade below this graph because there is a less than symbol. So solid line, I'm going to shade below, and I'm going to do this in pencil, making my diagonal lines go in only one direction. For my second graph, I'm going to start at the +3. I'm going to go up 2 over 1 or down 2 left 1. I'm going to make this a dotted line because it's not equal to, and I'm going to shade above because there's a greater than. So if I make this a dotted line and I shade above this line, that would be this part of the graph. Now the place on the graph where the two shaded regions intersect should look like it has crisscrosses in it because I shaded in two different diagonals. So I would make this section of the graph much darker than the other ones. And I could even, if I wanted to, erase the other sections where there was shading because those are not part of this final solution. Last but not least, we learned how to take a graph that was already provided to us and write out the equations or the inequalities that it came from. So to figure this out, I'm going to start with this solid line. I'm going to call that my purple line. So if I make that line purple, it's a nice solid line. The purple line, the slope of this line would be, if I count from here to here, down 1, 2, 3, 4, 5 over 3. And the y-intercept of this line would be -2. So I would put y and then leave a space and put -5/3 x minus 2. Then I notice that my line is solid and that the shaded part is below the line. So I would make my symbol a less than or equal to. Next, for the dotted line, I'm going to call that my green line. So if I make that line green and dotted, for my green line, the slope and the y-intercept, let's see, for the y-intercept I would have 2. For the slope I would do down 1, right 3, so -1/3. So I would write y and then a space, -1/3 x plus 2. Now my shaded part is above that line and it's dotted, so I'm not going to put an equal to symbol. I hope this helps to summarize everything we've done in these 2 sections, and we will see you tomorrow for some practice. Thank you so much for watching.